All right. Good morning once again. We continue with our discussion of the past exam, the recent test that you guys discussed, did. In the previous lessons, we did question 1. We also did question 2. This lesson, we will be discussing question 3. That's the question we are going to be discussing for this lesson. Just make sure you have a calculator with you so that we make it an interactive lesson. You know, there is a time when you will need the calculator, and there is a time when you will, need to note down 1 or 2 things. So please make an effort to have a calculator with you, and any other additional material, a piece of paper or some not stick, a book or something to note a few things down. Otherwise, let's get started. I will be sharing with you right on the screen the question paper so that we get started. In case you don't have a copy of the question paper right with you, you can rely on the one I'm sharing on the screen, as that is the exact copy that we will be using. So there we go. Here is a copy of the question paper. I guess you are able to see it. We did question 1, which was about log function and hyperbolic function. We did question 2, also about sketching a function. Now question 3 is what we are going to do today. So just make question 3 a little bit big. So question 3. All right, let me see. Yeah, so this is question 3. I was just trying to make it big enough so that it will fit on the whole screen nicely. So question 3, part 1. Question 3 is divided into 2 parts. Part 1, 3.1, and part 2, 3.2. And again, part 2 is divided into 3 parts, 3.2.1 up to 3.2.3. So let's get started. Now, the first question is that from first principles, determine the derivative. This f prime x means the derivative of the function f, if f of x equals 9 minus x squared. Now, when you are required to determine the derivative of a function, okay, you can use a number of methods. You can use basically 2, first principle and the formula. Now, in this question, we are restricted. We are supposed to use the first principle. And so how do you use first principle to determine the derivative of this function? Well, let's get onto a new page where we are going to do the what? The calculation. So this is 3.1. Just making it big enough so that you can see. 3.1. There we go. Now in this 3.1 that we are dealing with, this is the function. The function f of x is given as 9 minus x squared. And this is the function whose derivative f prime of x is required. And so for this, we can then write that since f of x, okay, since the function f of x is given as 9 minus x squared, to determine the derivative of this function, 9 minus x squared, we use a formula, okay? We use a formula, and that formula is written as the derivative, that is the derivative of a function f of x is given by the limit, okay? It's given by the limit as h tends to 0 or gets closer or approaches 0, okay, of the function f of x plus h. Just put the whole formula first right here. Yeah. So for this, can even put it inside another bracket. Yeah, let me just put like that. So here we have f of x plus h, x plus h minus f x divided by what? Divided by h. So yes, this is the formula that we do what? That we use. Now, sometimes this large bracket, this other one here, is not very necessary, but it's fine. You can still put it, okay? You can still have it there, or if you don't like to have the bracket, it's fine. You can ignore the bracket, but this is the general formula. Now, you notice that from this formula, f of x is known. It's given here as 9 minus x squared. What we don't know is the value of f of x plus h. And the question is, can we determine f of x plus h? Yes, we can determine f of x plus h. So how can we determine f of x plus h? Well, to determine f of x plus h, we have to use this expression 9 minus x squared. Only that where there is x, we now substitute x plus h. That way, we can determine the value of what? We can determine the value of f of x plus h, which we can then substitute right inside here. So let's just have it right here as f of x plus h, that is x plus h. You could earn $600 per year listening to the music you love. F of x plus h equals 2. So as I indicated, we use this very same expression, only that where there is x, we now substitute x plus h, okay? So when we do that, we will be having 9 minus, initially, 9 minus x squared, okay? That is what we would be having initially. It would be 9 minus x squared. But now notice that instead of having x, we have to substitute x plus h for x. So that means we are now going to what? We are going to have, instead of x, let's have a bracket there, we will be having x plus h, which we write as x plus what? Plus h. So that is the step we have. Now it's a lot easier to simplify. It's much better to simplify this expression before we substitute here, so that we don't, have double work. So that then means we will be having 9 minus, so when we square what is here, what we get should first be kept inside the bracket, because this negative sign or this minus which is outside the bracket is going to affect everything which will, which will come out from this bracket here. So it's much better in this step, we first continue having the bracket. So now when we square x plus h, that is like x plus h times x plus h. That will give us what? That will give us x squared, okay? That will be x squared plus 2xh, then plus what? Plus h squared. That's what we are going to be, that's what we are going to be having when we what? When we square x plus h. Now, one more step. we can then open the bracket for this. And if we do that, what we will get is going to be 9 minus, the whole thing will be negative. So we'll be having the minus of x, okay, but squared. Then we will also be having the minus of 2xh, then the minus of what? H squared. Okay. So that's what we are going to be having as the value of f of x plus h. Now, much more simplified. Okay. So f of x plus h now takes what? Now takes this value here, this expression, which is 9 minus x squared minus 2xh minus h squared. So we have now got the value of f of x plus h. The next thing is then to do what? Is now to substitute in this expression. We have to substitute in this expression. So to substitute it right in this expression, we will then have the derivative of f of x now equals to the limit. Okay. Let me see if I can just try to write this again here. Not allowed. All right, fine. So we'll be putting the limit. The limit as h approaches 0, as h approaches 0, or as h tends to 0, or as h gets closer and closer to 0, of what? Of the expression f of x plus h, which in this case is 9 minus x squared. Okay, that's what we are going to start with. It will be f of x plus h, this one here. This is what we now want to first deal with, f of x plus h, which is what we have right here. And that is going to be 9 minus x squared. Okay, 9 minus x squared minus 2xh minus 2xh, then minus h squared, minus h squared. That's what we have for f of what? F of x plus h. Now, from that, we have to take away f of x. Okay, do we have f of x? We do. F of x has been given as what? F of x has been given as 9 minus x squared. Well, let's put it right here as 9 minus x squared. So we'll be having minus, well, we could first have a little bracket and we put inside here 9 minus what? Minus x squared. So now 9 minus x squared is what we have for f of x. Then we later divide by h. That's what we have so far. Now, the other thing we want to deal with is we could open this bracket here. There isn't a need to have it. So you know what we can do is, well, let's just remove the bracket. And when we remove the bracket, what we are going to have is that this minus will make the 9 negative, and this minus still will make the what? Will make x squared positive. In other words, what we are going to be having there will then be minus 9, okay, plus x squared. That's what we are going to have. Now, from there, the next thing we want to deal with, okay, is to simplify what we can simplify, okay? So in the next step, we then have the limit as h approaches 0, or as h tends to 0, of our expression, which is what? The expression is, now notice that here 9 and 9 will cancel because we have a positive 9 and we have a negative 9. That will cancel out. Then the other thing is we also have x squared, which is negative here, and this x squared, which is positive. That will also cancel. We are going to be left with minus 2xh minus h squared. That's what we are going to be left with. That is minus 2xh minus what? Minus h squared. That's what we are going to be having right away. Then we will keep the what? The denominator. Now, in the next step, we seek to simplify what is inside this bracket here. Now, we notice there is h here and there is h there. We can factor it out. And when we do that, what we'll be having, well, it's going to be, in this step, we say the limit as h tends to 0, as h tends to 0 of this expression right there. Now, I indicated that since there is h here and there is, there are two h's here, we can factor one out. So when we factor h out, we'll be having outside h like that. Then inside here, we are going to be having minus what? Minus 2x like that, minus one value for h that way. Then now we will be having the denominator as h. All right. From here, you notice that we can cancel these two. We can cancel this and we cancel that. So when we cancel the two, what we are going to be left with is going to be the limit as what? The limit as h approaches 0, of minus 2x minus h. That's what's going to be left. Okay, minus 2x minus h. So we write it as minus 2x minus h. Like that. So at this stage, we then now substitute 0 for h, okay? At this stage where we have reached, we substitute 0 for h. And when we do that, what we get will now be, the limit, okay? Is going to be the limit as h approaches 0 of what? Of minus 2x minus 0. That is as h approaches 0 of minus 2x minus 0. That's what we are going to be left with. And we can then conclude that the derivative, okay? We can then conclude, because from here you see that the limit is going to be the limit of minus 2x. We now don't have any value for h here. So this will simplify to minus 2x. And so we conclude that the derivative, okay, sometimes known as the differential coefficient of the function f of x is now equals to minus 2x. So yes, these are the steps to follow. You just need to make sure you have the formula correctly written, okay? Now, after getting the formula correctly written, as indicated here, the thing you want to find out is if you have the value of f of x, which most time is given, okay, in the question. As here, 9 minus x squared. Then the other thing is you want to ensure that you have the correct value of f of x plus h. F of x plus h will not be given, but they will give you f of x. The only thing now is to find f of x plus h, which you find by substituting x plus h for x in the expression 9 minus x squared. You simplify that to get this. After that, you can go ahead to substitute. Now you have to substitute correctly because the plus and minus sign which will appear, which always, you know, participate in the operation or in the calculation. If you don't mix it nicely, it will affect your calculation. I noticed a few of you were having difficulty with expanding f of x plus h. F of x plus h must be expanded nicely, and you have to take care of the what? Of the minus, which comes before the x squared, okay? If you stop here with your expression for f of x plus h and you substitute right away, it will be a double work for you. So it would be better you find the final expression for f of x plus h before you substitute in the what? In the formula. That way, you can't go wrong. So when you substitute it and you simplify it the nice way, you can only do what? You can only mix it up in the final formula here in the substitution, which will again come with the requirement to simplify. And when you do that, you can go ahead to find the value of f of what? The derivative of f of x, which is minus 2x. Well, if there isn't a question, we can move on to the next question, which in this case is what? Is 3.2. So 3.2 is the next question. What are we required to do in 3.2? Well, in 3.2, we are required to determine the derivative of 1 minus 6 square root of x cubed. Then later, this and that. Now, notice that for question 3.2, part 1, 2, and part 3, we have not been restricted, okay? We have not been restricted. There is no mention that we have to use first principles. Now, because we are not restricted, we can use any method. And the method, first principle, tend to be a little bit long. And you know, in mathematics, the longer a step is, or the longer the steps to the solution, the much more complex things can get, and you are a lot likely to make mistakes. So for this, what we are going to do is we will use the other formula. So the question is 3.2.1 that we have to do what? That we have to solve. So we say 3.2.1. We have to find the value of what? We have to find the value of dx, that is the derivative of the function with respect to x, like that. Dx of what? Dx of, let me just use a different bracket. This one is not the best for us. Okay, so dx of what? Dx of 1 minus 6 square root of x cubed. All right, so there we go. We have it as 1 minus 6, okay, times square root of x cubed. Now, I noticed this was also an issue while I was marking. You guys were having difficulty with simplifying 6 minus, you know, rather 1 minus 6 square root of x cubed, especially this part here. Simplifying it was an issue for so many of you. So I think we are going to take a step and we fix it out so that, you know, next time you don't have a similar problem. So that then means, just for the sake of simplification, you know, before even starting the use of the formula, we can write dx as, okay, we can write dx as one minus 6. Now, this one here, the square root of any number is the same as that number raised to power 1 divided by 2. That's the meaning of square root, okay? what I'm trying to say here is x cubed being under a square root sign like this. X cubed being under a square root sign can be written as x cubed with what? With another exponent. And the exponent in this case is 1 divided by 2. So let me raise it right away so that you can see what I'm talking about. So here you will now be having what? The exponent is 1 divided by 2. That is the meaning of square root. In other words, the general case is that the square root of any number, think of a number like a. So the square root of a number like a equals to a raised to what? A raised to the power of 1 divided by 2. So normally it's much safer to have it inside the bracket. So this is what we are talking about. You see, 1 divided by 2. Like that. That's the general rule. And that's the rule we have what? We have applied here. Because x cubed is under what? It's under a square root. Okay? So now, because of this, this is just some rough material. And we can then go ahead to do what? To simplify this one more step. So that will give us d of x, okay? The derivative of x being right. There we go. Now we have 1 minus this step of the simplification is very necessary because you don't want to go wrong in your what? In your substitution. When we simplify it, the formula that we have to use, that formula is a lot easier when we have a clearly defined exponent. If we have exponent, which is a number, not like in a square root or something which is compounded, we easily deal with the formula when we have the what? When we have a number as the exponent. That's the reason we are moving away from the square root of x cubed to what? To this type of expression. And so this will give us finally x raised to 3 divided by 2. That is what happens when you multiply 3 times 1 over 2. You get what? You get 3 divided by 2. So let's raise it to 3 divided by 2. Yes. Now from here, okay, from this step, we can then simplify, okay? Notice what we have done here is to write the original expression in a way that we can apply the formula in solving, okay? So now we will use the formula, okay? We say we will be using the formula. And what is that formula? Well, the formula is that the derivative, okay, of a function, the derivative of a function of x, just write like this, equals to what? Equals to x, rather n x raised to n minus 1 raised to n minus 1. This is the derivative if, okay, that is if f of x is what? If f of x is x raised to n. Like that, you see? So now that is what we are going to be dealing with at this point in time. Now the formula we have, let me now clear this. It's done for this. All right, so what we are saying here is if the function we are differentiating is a function of x given by x raised to n, x with the exponent n, x with the power n, then the derivative of this function is going to be n times x exponent n minus 1. Okay, so very much like if this is what we are dealing with, then we need to identify n, because that is what is used a lot in this case. We need to know what is n in this case. Now notice that we will have to differentiate one, then later also differentiate what? This other one. But the derivative of a constant is 0. Okay, so the derivative of a constant is 0. So generally we can just write this. We can therefore say the derivative, or rather d of x, if the expression is 1 minus 6x raised to 3 over 2, okay, so 3 over 2. So if this is what we have for dx, that is the d of x, the derivative of x, of a function of x, if this is the expression, it will now be, well, the derivative of the constant first, then the derivative of this other one. The derivative of the constant is 0. Then now we deal with the second one, that is minus. We want to factor 6 outside so that we can deal with x. Okay, now notice that the derivative of x with this is going to take this form. So it's better for us to have what? To have a bracket. Now, here, n is 3 divided by 2 by comparison, okay? When you check through, n is 3 divided by 2 and x is this one. We have kept this away. We are now dealing with this x raised to 3 over 2. So one thing you notice is that n is 3 over 2 and x is here. So this is what we are supposed to have. That means the n that we have as the power must now appear as the what? The coefficient. So it's 3 over 2. Then that is what we are going to be having here. Okay, we'll be having 3 over 2 as the coefficient right away. 3 over 2 for this. Then again, we have to take away 1 from x, rather from n. Remember, this is the coefficient of what? This is the coefficient of x. Okay, you can even put times there, coefficient of x, okay? Then now, what is remaining for x is that this n, which was up here, we have to take away 1 from it. But notice that the n, which is up there, is 3 over 2. So we raise this to 3 over 2. Okay, after raising it to 3 over 2, the next thing is we take away 1 from it, which is exactly this one here, okay? So n minus 1 is going to be 3 over 2 because n is 3 over 2, then minus 1. This will give us what exactly we are looking for. So that will give us minus, because 0 minus that is 0. So we'll be having minus 6. Okay, we first want to simplify a little bit what is inside the bracket, or we could even expand it right away. So when we multiply this, this is going to be 6 times 3, which is 18. 18 divided by 2 is what? Is 9. So instead of having 6 there, we now be having 9. Then now we are remaining with what? We are remaining with x raised to 3 over 2 minus 1. 3 over 2 is 1.5, you know? So 1.5 minus 1 is 0.5 or 0.5. So we are going to be having x now raised to the exponent of, okay, raised to, or the exponent is 1 over 2. That's what we get when we take away 1 from 3 over 2. So we put it right here. This is going to be 1 over 2. Okay. Now notice that we can still simplify this. Well, you could stop here, but how about if you could write it nice so that you have minus 9. Now we had already seen that any number expressed with the exponent of 1 divided by 2 is the same as the square root of that number. We just discussed that, so we can write it as the square root of x. Now this becomes the solution of this question here. Okay, so that is where a lot of you I saw got stuck. The part was mainly in simplifying, you know, the exponent of x. And I think I have been, you know, I discussed it in detail enough for you to understand. So the thing is, the square root of any number is the same as that number raised to what? Raised to a negative, rather raised to the exponent of, or raised to the power of 1 over 2, which is what we have here. Then now you can simplify to this. Then you do what? You identify n. Then you use the formula, which is nx, n minus 1, for what? For xn. So if you identify that n is 3 over 2, then you just substitute. And when you do that, what you get is the final answer of this. So yes, that's how you would determine 3.2.1. We can now go to 3.2.2. So 3.2.2 is this expression. We have been given y equals to 8 minus 3x raised to the power of 6. Okay, so let's write that down. We have been given that y equals to what? Well, let me check it out again. 8 minus 3x. 8 minus 3x. X has got what? X has got exponent of 6. Yeah. Then now we also have the what? The denominator, which in this case is 8. So the question is, how do we handle this type of thing? Well, before we differentiate this, we need to simplify it a little bit, okay? We have to simplify it. And simplifying this, well, let me first check if I've written the question nicely. 8 minus, oh yeah, there is what? There is x raised to the power of 5 as the denominator. 8 what? 8x raised to the power of 5. Like this. Yeah, that's what we have. So let's first simplify this before we use that formula to do what? To differentiate. So how are we going to simplify this? Well, we just say y equals to what? Equals to 8 divided by, we have to break it down, this 8 over that minus, okay? Then we also separate this one here. That's what we want to do first. So here we are going to be having 8 divided by 8x raised to the power what? Raised to the power 5. Then here we are going to be having 3x raised to the power 6. 3x raised to the power 6. And what? And 8x raised to the power 5. Like that. So that way it's going to be a lot easier for you to see how we are then going to what? To simplify this whole thing. And so that will give us y equals to 8 divided by 8 will cancel. So we are simply left with what? We are simply left with 1 for the numerator, okay? And for the denominator, we now have x raised to the power of what? 5. That's what we got. Then the next term is going to be, now notice that we cannot do what? We cannot reduce this to 8 over 3. So we will keep it like that. But we can reduce what? We can reduce this expression here. Because this is x power 6, this is x power 5. So we can take away, according to the law of exponents, we can take away what? 5 from 6. And that will give us 3 divided by 8, okay? 3 divided by 8. Then here we are going to be having x and only x. Because now when you take away 5, from 6, what do you get? 5 from 6 gives 1. So x with the exponent of 1, not necessary to put it. Now, this first term, we can simplify it a little bit, okay? 1 divided by x raised to the power of 5 can be written as x raised to the power of what? Raised to the power of -5. You see? Raised to the power of -5. Yes. Now, from there, we can go ahead to do what? We can go ahead to differentiate. Okay? We can therefore say the value of dy by dx. Okay? We can therefore say the value of dy by dx, or simply y prime. That's fine. It's going to be, now, notice that in this case, n is what? Is -5. And so we'll be having from nxn minus 1, okay, from the formula, which we have already written it up here. This is the formula, nxn minus 1. We already have x, we have x, n is -5. So that means we are going to put -5 here and -5 there. -5 is supposed to appear where? At 2 separate places. So we'll be having it as -5 down there with x, then again -5 up there. Okay, so let's have it right here as -5, but we have to take away 1 from it. So we have -1. That's for the first term. Then for the second term, we have 3/8, okay? 3/8. Now 3/8, like this. Then there is x. Well, how would we differentiate this? The derivative of x is just 1. Is 1. So 1 times 3/8 will remain the way it is. So we can then go ahead to simplify the what? To simplify this one. This is going to be -5 now, like this. Then x raised to what? Raised to the power of -6. That's what we now get. Like that. Okay, minus what? Minus 3/8. Now, you could write this as the what? You could write this as your final answer. But how about if you could simplify it just a little bit? You know, how about if you could simplify it a little bit? Because notice that the first term can be simplified. You know, the first term can be simplified. And so if we simplify the first term, what we are going to get is going to be a much better representation, which in this case is what? Which in this case is going to be -5. Then we just bring this down. Okay, let's just put it down here. X with what? With a 6. The exponent will now become positive, not negative, like that. Then minus 3/8. 3/8. Yes, that's what we get as our final answer, much more simplified. Okay, so that's the value that we get. And so from here, we can move on to 3.2.3, which is the last question. Okay, which is the last question for part 3. So 3.3.3, what's that going to be? No, 3.2.3. So let's see what that question is right here. What's the question? Well, f of x is x minus this. Oh yeah, I noticed this. This also disturbed a lot of you guys while you were what? While you were differentiating, especially the part of expanding this. You know, the part of expansion of this one disturbed you guys a lot. So let's work on it. So how do we do that? Well, let's just write the question down and we see how we can navigate that through. So we have been given that f of x, equals to what? Equals to the square, okay? The square of some quantity. All right, so what is that quantity? Well, the quantity is x minus what? Minus 3 over x. This is what we are dealing with. Now, we have to square this. How do we square this? Well, just right away, let's see how we are going to square this. This is the same as this quantity times itself, okay? The quantity times itself. So what I'm going to do, just to make it a little bit easy, I'm going to break it into two separate brackets as what? X minus 3 over x in one bracket. X minus 3 over x in one bracket, then again x minus 3 over x, so that you can see how this can be simplified. So we again have 3 over x right here. Like that. That's the meaning of square, okay? That's what we are dealing with. And so how is this going to appear then? Well, to square this, then we have to multiply x times x, okay? When we multiply x times x, what we get is what? Is x squared. Yes, that's what we get. Now, the next thing is we have to multiply this x times what? Times 3x. What is that going to be? That's going to be 3x divided by what? Divided by x. Yeah, I'm just taking this slow step so that you guys follow this nicely, because I noticed it was an issue for you. So this is what we have for x times this quantity here. Then now we have to multiply this 3 over x times the whole of that, okay? The first thing is to multiply this x times everything here. So when we multiply x times x, we get x squared. Then when we multiply x times 3x over x, we get 3x. Sorry, not 3x over x. When we multiply x times 3, we get 3x. Then over x. We are done with that. Now the next thing is to multiply 3x, rather 3 over x times x. This is going to be 3 times x divided by x, also minus. Okay, so let's put it down. Say minus 3x, okay, over x. All right, now the next thing here is to now multiply what? 3 over x times 3 over x. That is 3 over x squared, right? Rather, that is going to be 3 over x times 3 over x, meaning 3 times 3, 9. X times x, x squared. And that is going to give us 9 divided by what? X squared. That's what we have. 9 divided by x squared. Like that. Now, what's the next thing that we have to deal with? Well, the next thing that we want to deal with in this case is to simplify this. Now, notice this x and this x can cancel. And also this x and this x, they will cancel out. We are basically left with the minus 3 or negative 3 minus 3. What will that be? Well, let's first write this down. This is x squared minus negative 3 minus 3 is 6, negative 6. Then now minus what? Minus 9 over x squared. Minus 9 over what? Over x squared. So we have that x squared. Like that. All right. So now, instead of dealing with this 9 over x squared, instead of just copying it, since this is a step of simplification, let's simplify this. Let's take this x squared up, so that instead of having 9 over x squared, we just have 9 times x, but this time with the what? With the negative 2 as the what? The square in this case is now going to be minus 2. So this way we can then simplify using the same what? Using the same formula. And what is the formula? Well, the formula is that if we have identified the value of x separately, then the exponent of x is called n. And for that, the derivative is nx n minus 1. And so that's going to give us what? That's going to give us, well, here, for this first term, n is 2. So we will have 2 here and 2 up there, then minus 1. Okay, so let's just deal with that right away. So we'll be having 2, okay, times x, then the 2 which is up here, from it we take away 1. Then when we differentiate 6, we get 0. Okay, we differentiate one term at a time. The derivative of x squared is what we have got here. Then the derivative of 6 is 0. Now we want to differentiate the next quantity, which is what? X raised to the power of negative 2. This one is a constant, so we just keep it there. We say minus 9 minus 9. Okay, you know, we could put some small bracket there. All right, so from here, what we have is this. X is here and n is negative 2. So that means we are going to have negative 2 here times x. Then what? Then we'll be having another negative 2 up, right? Like this. Okay, we'll have another negative 2 up. And from it, we take away 1. Then we just simplify. Okay, then we just simplify. So when we do that, we will get the final answer. And what is it going to be? Well, we can then conclude. But maybe before we conclude, let's first write this. This is going to be 2x minus 0. We don't need to write that. Minus 9. All right, so now notice this is minus 9 and there is also a 2 here. You know, just simplify that. This is going to be plus because minus times minus is what? Is plus. This is going to be 2 times 9, which is 18. And now we are left with x raised to the power of negative 3. Okay, that's what we have. X to the power of negative 3. Like that. So from here, we can now, well, we could, you know, stop here. Or we could simplify it further. There is one more step we could include. And what's that step? Well, we just say the derivative of the function f of x is now equals to what? Equals to 2x plus 2x plus what? 2x plus 18, 2x plus 18 over 2x plus 18 over x cubed. So let's just write this down. 18 over x cubed. Now, just before we conclude, looks like there is something we need to check out. This is 3. Let's first check. There is something as if there is a small problem with the sign over there. Just check it right away. Okay. Oh, yeah. The problem is here. We did not indicate this nicely. You know, when you multiply this quantity here times this other one, you get 9 for numerator, correct? X squared for denominator, but there is this minus and minus, which is supposed to multiply this one here, you know? So this one would become positive. And so this one would also be positive. See that? So it's good to check the steps of your working because this is a very likely thing that can happen during your calculation. So this is going to be a plus. And now you see we have 9, which is positive, and 2, which is negative, meaning this is going to be what? This is going to be negative. And so the final answer will also have a negative here. So yes, this is how you would complete the derivative. Yeah, this is how we would complete it. And the final answer would be this. Yes, I have seen your message and I've checked it right away. I've fixed it already. So yes, this is how we differentiate it. Just let me know if you do have a question. In case you don't have a question, I think we can stop here so that you guys can move on to the next lesson in case you do have one. Or in case you're free, yeah, then you can try to redo this by yourself. You know, the question is right here. The question is here. Just try to do this for practice. You know, you have some little time. Try doing this by yourself. 3.1, 3.2, you know, try, you could also use a first derivative for this. There isn't a problem, even this one and that, okay? Only that it's going to be a very long process. And because it's going to be a very long process, you know, you can easily make mistakes, but I encourage you to try that too. Otherwise, I guess this is where we have to stop so that we can, you know, join the next class right away. Thanks for your time. Let's link up later.